Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problem number 6 of the 2017 AP Calculus Free Response Question. In this problem, we're going to be using the table of G and G prime and the graph of H to solve differentiation rules problems. This is a thorough consideration of the problems. We're going through every detail. If you like something really quick, you can just go to our website and take a look at the transcripts of this presentation so you can go through it at your own pace. All right, so for question number 6, the A part, you've been assessed on how to find the slope of a tangent line. Okay, you're given a table of X, G, and G prime, and also the graph of H. And question 6 reads, let f be the function defined by f of x equals cosine 2x plus e to the sine x. Let g be a differentiable function. The table above gives values of g and its derivative g prime at selected values of x. Let h be the function whose graph is constituting of 5 line segments is shown in the figure above. Okay, so A part says find the slope of the line tangent to the graph of f at x equals pi. All right, so what's our game plan here for finding the slope of a tangent line at a particular x value? So let's go ahead and outline our plan of attack for this problem. So what we're going to do, remember, whenever you're looking for the slope of a tangent line is a two-part process, okay? So for this one, we're going to find the derivative. So first find the derivative of f. And if you take a look at what f looks like, it has two composite functions. So since they are composite, we're going to be using what? What method are we going to be using here? We're going to be using the chain rule, okay? Using the chain rule. All right, so remember you do your calculus first before you do your arithmetic or algebra. So we've done this is a calculus step, and then after that you're going to evaluate the derivative of f at the specified x value. All right, so that's basically what the slope of the tangent line is. Now let's go ahead and write down the formula that's going to guide our problem solving process. So the slope of the tangent line, let's call it SOT, at let's say a specific a value is the same thing as the derivative of a. Okay, and this is a two-part process. First part is the calculus step where you find the derivative, and then the second part is the arithmetic step where you evaluate the derivative at the a value. All right, so don't forget Navitt-Stiller. When you're looking for the slope of the tangent line, okay, looking for the slope of a tangent line is the same thing as looking for the derivative or the rate of change, okay? So that's basically what we are doing in this problem. Okay, so let's start off with part 1. For part 1 of the problem, we want to find the derivative, okay? Basically the slope of a tangent line at any arbitrary x value, and then we'll fix it after that. So the function is cosine 2x plus e raised to the sine x. So we're going to be using the chain rule twice here. Okay? All right, so let's go ahead and do it. All right, so I'm going to decompose the functions just to show you exactly what's going on. So for the first function, the outer function f is cosine x, okay? And then the inner function is 2x. Let's call that g, okay? So that's for the first function. All right, and then we're going to differentiate that. So the derivative of the outer function is, derivative of cosine is negative sine. And then the derivative of an inner function is, oh snap, g is not 2. It's not x. G is 2x. Sorry about that. So g is 2x. All right, so the derivative of the inner function is 2. Okay, so if we apply the chain rule in differentiating the first function cosine 2x, is basically the derivative of the outer function evaluated at the inner. So we're going to take the inner function and plug it into the derivative of the outer and multiply it by the derivative of the inner function. Okay, all right, so f prime of x, the derivative of cosine 2x is negative sine x. So instead of putting x there, we're going to put in the inner function. Negative sine x evaluated at the inner times the derivative of the inner function, which is 2. Okay, so this is the derivative of cosine 2x. Okay, now let's take a look at the derivative of e to the sine x. This is a composite function, so we're going to break it down again, okay? All right, so the outer function here, let's make it green. The outer function is e to the x. So we're going to call the outer function f. And then the inner function is sine x. Okay. All right, so let's call that g. So we're going to differentiate both of them and then use the DOED or the chain rule to finish it off. So the derivative of e to the x is just e to the x, e for easy. And then the derivative of g, the derivative of the inner function, is cosine x. Okay. All right, let's DOED this real quick. So let me put a split here so we don't get confused. All right, so we're going to have the derivative of the outer evaluated at the inner. So we're going to take g of x and plug it in here. That's f prime of u times u prime, which is cosine x. Okay, so let's put it together. So it's plus derivative of outer evaluated at the inner is e to the sine x times the derivative of the inner, which is cosine x. Okay, all right, let's make it look a little bit pretty here. So we have, what do we have? F prime of x. F prime of x is negative 2 sine 2x plus e to the sine x cosine x. All right, that's the answer to the first part. And then the second part, now that we are done with the calculus step, we're now going to do the arithmetic step or the algebra step, okay? So for the algebra step, we're going to evaluate the derivative at the specified x value, which is pi, okay? So f prime of x, let's just rewrite it so we don't make any mistakes, is negative 2 sine 2x plus e to the sine x cosine x. All right, and then f prime of f prime of pi, we just plug in pi into all the x's, okay? So we have negative 2 sine 2 pi plus e to the sine pi cosine pi. Okay, so we have pi and 2 pi here. So we're going to be using the unit circle, or you can use your cosine and sine functions. Those will work perfectly well too. So let's just use the unit circle. All right, so we have the unit circle right here. And then we're going to concern ourselves with just pi and 2 pi. So on the unit circle, this is pi. Pi is 180 degrees. 2 pi is double that, 360 degrees. Coordinates here, the coordinates here are, this is the unit circle. Basically, the radius is a unit, okay? So it's 1, 0. And then over here, it's negative 1, 0. So as we know from the unit circle, y sin, right? The y coordinate is sine, and the x coordinate is cosine. In this particular case, there's going to be 0 degrees. And then here, the same principle applies. Cosine is the x coordinate, and sine is the y coordinate. Alrighty. You could use the graph. I like using the graph, but some students like this unit circle. It doesn't matter. Anyway, so let's go ahead and finish it off. F prime of pi is going to be -2. Sine of 2 pi is the y coordinate here, which is 0. So sine of 2 pi is 0. Plus e to the sine of pi. Sine of pi is 0 also. So e to the 0 times cosine of pi. Cosine of pi is the x coordinate here, which is -1. All right, and then if you simplify that, your final answer is going to be -1. All right, so how was this problem scored on the AP exam? This was a 2-pointer, a 2-point problem. You just got 2 points for arriving at the final answer right here, -1, and you get your 2 points, okay? Alrighty, let's take a look at question 6b. It says, let k be the function defined by k of x equals h of f of x. Find k prime of pi. Alright, this problem is exactly the same as the previous one that we did, okay? K prime of pi is the same thing as the slope of the tangent line of k, slope of the tangent line to k at pi. That's basically what it is. It's just similar to exactly what we did before. So our plan of attack will be the same. So let's outline it again. So this one we're being assessed on how to find the derivative of the point or just the slope of a tangent line. All right, so remember when you're looking for the slope of a tangent line or derivative at a point, it's a 2-part process, okay? First of all, you have to do your calculus first before your algebra, okay? So find k prime of x, the derivative anywhere, using what differentiation rule are we going to use here? You notice that k of x is a composite function. So guess what? We're going to use a chain rule again. All right, so you see the importance of the chain rule in the AP exam. Okay, so after the calculus step, you're going to go ahead and do the algebra step. In this part, you're going to evaluate the derivative that you found in part 1 at the specified x value, which is pi. Okay, all right, let's do it. So for part 1, we're going to find the derivative at any point, k prime of x. So we have k of x, which is a combination of h and f. So k of x is equal to h. You know what? Let's do this. Let's color code it. Let's make it look pretty here. So k of x is equal to h composed with f of x. Alrighty, so we're gonna make our chain rule look colorful here. Alright, so we want to look for the derivative of k. So what we're gonna do first is decompose k. Alrighty, so the outer function is h. Let's call that f. So let f of x be h of x. And then our inner function is f of x. Let's call that g. Some people like to call it u. It doesn't matter. So let's call it g, or you can call it u. All right, so we're going to be using DOED here to differentiate our composite function. All right, this is the chain rule. So derivative of the outer evaluated at the inner times derivative of the inner. So in order to DOED this problem, we need to differentiate both sides. So f prime of x is equal to h prime of x, and then g prime of x. The derivative of the inner is equal to f prime of x. Okay, all right, so now what we're going to do is the derivative of the outer evaluated at the inner. So you're going to take the inner function and plug it into the derivative of the outer function. and multiply that by the derivative of the inner function. Okay, so our derivative, k prime of x, is going to be h prime evaluated at f of x times f prime of x. There is the derivative right there. Okay, now we're done with part 1. Now we're going to advance to part 2. All right, so for part 2, what we're going to do is we're going to just substitute pi for k. Okay, so k prime of pi is going to be h prime of f of pi times f prime of pi, like that. Okay, so in order to evaluate this expression right here, this function, we're going to be making use of some information that we know from part A. Okay, what do we know? We know that from the original problem, we know what f of x is. Okay, f of x is cosine 2x plus e to the sine x. All right, that's given. And also from part A, guess what? We know what the slope of the tangent line is at pi, and that's exactly what this is. This is SOT at pi. This is the same thing as the derivative. And then from A, what do we know? From part A, we know that f prime of pi, we already did this, is equal to -1. All right? So we're going to use these pieces of information to solve this problem. Okay, and then we also know that this graph that's on the right here is the graph of what? This is a graph of h. Okay, all right, so k prime of pi is going to become h prime evaluated at f of pi is going to be h prime evaluated at f of pi, which is, so this is f of x. Okay, so f of pi, you just plug in pi into the x's here, so it's going to be cosine 2 pi plus e to the sine of pi, e to the sine pi, close that, times f prime of pi. So from part A, we know that f prime of pi is -1. Bam, like that. So let's simplify. So we're going to have h prime of, now we're going to use our unit circle again to help us out. So let's draw a unit circle right here. We just need sine pi and cosine pi, okay? No, I'm sorry, we need cosine 2 pi and sine pi. So draw a nice little unit circle. Let's see, so right here we have 1, 0, that's for 2 pi. And over here we have -1, 0, and that's for pi. So cosine is the x. We already know that. Cosine theta, and then sine is the y. All right, so what is cosine 2 pi? So cosine 2 pi is just 1. Okay, we can see here the x coordinate. So parenthesis 1 plus e to the sine pi is 0. So e to the 0 times -1. Okay, so if we work this out, this becomes negative h prime of 1 plus any non-zero number raised to the 0 is just 1, right? So it's going to become negative h prime of 2. Okay, now we're going to have to use this graph to figure out what the derivative is. The derivative for h at 2. Okay, so remember we talked about Navier-Stiller earlier. If you're asked to find, so let's write it down again. if you're given a graph and you're asked to find the derivative, remember that the derivative is the same thing as the slope of a tangent line. And if the point under consideration is contained in a line segment, then that entire line segment is your tangent line, and the slope of the line is going to be your derivative or the slope of the tan line. All right, so what are we saying? Well, what we're saying here is at point x equals, this is 2 right here, the slope of this entire region is exactly the same because it's a straight line, which means that the derivative or the rate of change is constant. So if we find the slope of this line segment, it will tell us exactly what the derivative is here because the line is a tangent line. Okay. All right, so let's go ahead and find the slope of this line segment. We're going to use, what are we going to use? Elementary algebra here, rise over run. Okay, so the derivative is going to be, remember there was a minus here before, so minus rise over run. Rise over run from 0 to 3. Okay, so let's do it. So you have a negative rise here. So there goes your rise. Your rise is -1 since you're falling. And then your run is 3. All right, so just using elementary algebra, rise over run, we can find the derivative at 2. So the run is 3. So we'll plug that in here. So it's going to be negative rise over run. Your rise is -1 over your run, which is 3. And then when you multiply it out, your final answer is 1/3. There goes the answer to question number 6B. Okay, how was this problem graded on the AP exam? This was a 2-pointer also, although you have a lot of work to do here, but it was still a 2-pointer. So this is how this problem was graded. You earn 1 point for finding the derivative of k, so this is the first point, and then you get your second point for finding the derivative of k at pi, for a total of 2 points for question number 6B. Alrighty, let's go ahead and take a look at number 6C. It says, let m be the function defined by m of x equals g of -2x times h of x. Find m prime of 2. So we're looking for the derivative at a point again, or the slope of the tangent line. So let's go ahead and outline our plan of attack for this problem. So first things first, remember you when you're looking for the SOT or the derivative at a point, you do your calculus step first and then pre-calc, algebra, everything else afterwards. So we're going to find the derivative, find m prime of x using you notice you have a product of two functions here, using the product, and if you take a look at the first factor, the first function is a composite, so you're going to be using the product and chain rule and chain rules. After that, you do your algebra step. You're going to evaluate the derivative of the function at the specified value, which is x equals 2. Okay. All right, so let's go ahead and refresh our memory on what the product rule is again. So uv prime, the product rule is vu prime plus uv prime. Keep that in mind, and we know what the chain rule is, so we're not going to go over that. All right, so m of x is g of -2x times h of x. So the first function is our u, and the second function is our v. Okay, all right, so let's differentiate using the product rule. So m prime of x is going to be vu prime the derivative of g of 2x. So let's just let me just show you the steps so you don't get confused. G of -2x prime, vu prime plus u, g of -2x times v prime, which is h of x prime. Okay, all right, so let's differentiate. So m prime of x is going to be h of x times derivative of this. You're going to use the chain rule, okay? So the derivative of the outer evaluated at the inner is g prime of negative 2x times the derivative of the inner. Now you got to be careful here. The inner function is negative 2x, so the derivative will be negative 2. All right, plus g of negative 2x times, let's write that again, g of negative 2x times h prime of x. Okay, so we're done with part 1, which is to find m prime of x. Now we're going to advance to part 2, okay? So for part 2, you're going to evaluate your derivative at x equals 2. Alrighty, so what am I talking about? We're looking for m prime of 2. So m prime of 2 is going to be h of 2 times g prime of, now if you plug in 2 here, that's 4, right? So negative 4, g prime of negative 4. And then we have this negative 2 here. I need to put it up front. Plus GF, plug in 2 here again. You have negative 4 times h prime of 2. Alrighty. Now let's go ahead and figure this out. Now to figure this out, we're going to be using a combination of the chart that we have here and the graph of h. So let's start out by looking for h of 2. So m prime of 2 is going to be, now h of 2, just take a look at this graph right here. The slope of this line so we're looking for h of 2. What is the output value here? So the slope of this line is negative 1/3. So if you go down 1, you're going to go over 3. Okay, so what is this point going to be here? So basically you're breaking this into thirds. So if you go down 1/3, you're going to go over 1. If you go down 2/3, you're going to go over 2. So this is h of 2. h of 2 is basically going to be 2/3. So that value right there is 2/3. Sorry, negative 2/3. And then that value over there is negative 1/3. And then this value over here is negative 1. So following the slope, here, this part right here is going to be negative 2/3. So h of 2 is going to be negative 2 over 3 times g prime of 4, using the graph, g prime of negative 4 is negative 1. That again, it's negative 1 times this negative 2 still hanging out there, plus g of negative 4. G of negative 4 is 5 times h prime of 2. We already did that before. So basically h prime of 2, let's look at it again real quick, is the slope of this line segment right here. Okay, so remember the derivative is the slope of a tan line. If your line is straight, the tan line is the line. So the derivative here is basically rise over run, as we did in the previous problem. So your rise is negative 1 and your run is 3. That's your slope triangle for this segment containing these points right here. So h prime of 2, the slope is going to be negative 1/3. Okay, all right, and then if you simplify this, you get negative 4/3 minus 5 over 3, which is negative 9 over 3. And your final answer is negative 3. And that's the answer to question number 6, C. All right, so how was this graded on the AP exam? This was a 3-pointer. The first point you will get by correctly finding the derivative of m prime. Actually, you get 2 points for that. So all this work right here, this is to get to this point right here. Let me move this to the side. To get to this point, m prime right here, this is 2 points. And then evaluating this derivative at 2, give you another point. And that gives you a total of 3 points for question number 6C. Alrighty, let's go ahead and take a look at 6D. the question is as follows. Is there a number C in the closed interval -5, -3, such that the rate of change, instantaneous rate of change of at C is equal to -4? Justify your answer. All right, so when you're looking for a point in an interval where you have the slope of the tangent line equal a particular value, this, in a scenario like this, you're looking at the utilization of the mean value theorem. Okay, so let's take a look at that real quick. So we're going to be using a theorem here, not a formula. And then the theorem we're going to be using is the MVT, or the mean value theorem. All right, so we're going to break this down. We have the hypothesis and then the conclusion. Okay, so the scenario has to meet both cases in order for it to be true. So the mean value theorem is as follows. If you have the following, so the hypothesis is as follows. Condition 1, if f prime, I'm sorry, let me change the color. If f is continuous, if f is continuous on a closed interval, let's say AB, that's the first part of the hypothesis, and it's differentiable on AB. All right, so that's the hypothesis right there. Then, and then here you have the conclusion. There exists a C in the interval AB where, or such that, the slope of the tangent line f prime of C, like as you can see here, is equal to the slope of the secant line through AB, f of B minus f of A divided by B minus A. Okay, basically where the I rock is equal to the A rock. So these two together, part 1 and 2, this represent the hypothesis. This is the hypothesis right here. And then here we have the conclusion of the mean value theorem. Okay, so the question is, does this problem, this scenario that we're dealing with, meet both criteria? Let's take a look at the hypothesis first. Now, it's stated initially that G is differentiable. Well, that's convenient. So for the hypothesis, what do we know? Condition number 1, G is differentiable on that interval. G is differentiable on -5, 3. How do we know? We were given this piece of information. It's a given, okay? Now, how about continuity? Ladies and gentlemen, continuity is a condition for differentiability. Okay, so we automatically know that G is continuous. Also, how do we know that? G is continuous on that interval because it's differentiable. Okay, since continuity is a condition for differentiability. It is a condition for differentiability. All right, so since it's already differentiable, that automatically means that differentiability. That automatically means that it's continuous. Alrighty, it's just like in order for you to be in California, you have to be in the United States, right? So if you're in California, you're automatically in the United States. Okay, so differentiable functions are a subset of the family of continuous functions. So if a function is differentiable, is automatically, you can automatically assume that it's continuous, since all differentiable functions are continuous. Okay, so let me just show you a Venn diagram real quick. So let's say this is right here. This is differentiability. All differentiable functions are a subset of a bigger function, a bigger set of functions known as your continuous functions. So if g is right in here, just like being in California, right here, if g is there, then g is automatically in the set of continuous functions, namely the United States. So that's how we arrived at number 2. Okay, so we see that this scenario we're dealing with meets the hypothesis of the mean value theorem. Okay, so in order to arrive at this conclusion, we have to see if it satisfies the conclusion of the mean value theorem, where the average rate of change is equal to the instantaneous rate of change. So based on the conclusion of the mean value theorem, there is a C in this interval -5, 3, where f prime of C is equal to 4. Oh snap, not is g, sorry. Where g prime of C is equal to -4. Okay, so what we're going to do now is as follows. We're going to go find the average rate of change, which is g of, so in this problem, A is -5 and B is -3. Okay, the bigger one is normally the B value and the smaller one is A. So g of -3 minus g of -5 divided by b minus a. So what's b minus a? This is -3 minus -5. Okay, is this equal to, is it equal to g prime of C? So let's go ahead and work this out. All right, so to do this, we're going to be making use of the table that we're given to figure out the left side, the average rate of change. And then for the instantaneous rate of change piece, we're going to use what we're given earlier, okay? So if you work this out, g of -3, g of -3 is 2. Let's do that again. G of -3 is 2, right here. And then g of -5 is 10. Okay, we're good to go. Let's do it. So we have 2 minus 10 divided by -3. Minus times minus is plus 5. Is it equal to g prime of C, we're told, is 4. Okay. And then when we work this out, we get -8. No, this g prime is -4, sorry. -8 over 2. Is that equal to -4? -4 equals to -4. Check. So it meets the conclusion that we desire. Okay, so let's finish this off. What do we know now? Well, we're going to be able to say that the statement is true based on the mean value theorem. Okay, so therefore, by the MVT, or by the mean value theorem, there exists a C in the open interval -5 to -3, where the derivative at that point, or the slope of the tangent line, is equal to -4, the slope of the secant line. All right, on the AP exam, this was a 2-point problem. In order to get your first point, you had to use the conclusion of the mean value theorem to show that this is true. So you got 1 point here. And then the second point, by putting everything together and stating that the conclusion is justified using the mean value theorem. So you have to explicitly state this for a total of 2 points. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for the AP Calc exam, to give us a thumbs up. Your positive feedback is very valuable to us. Don't forget to subscribe to our channel for updates to other presentations such as this. More support resources can be found at mathgotserved.com. Do check it out. And if you have any questions or comments or requests, just post it in the comment section below. Thanks again for watching and have a wonderful day. Goodbye.